Hello and good morning friends, welcome to CEC-UGC live lecture. Dear friends, as you know, we have been talking a lot on operations research. This is our ongoing series, and under this series we used to learn every day. I mean in every lecture we used to learn new topics. In previous lecture we discussed about game theory. Today we are going to discuss on simulation. For this we have again with us in our studios Dr. Subhash, one of the renowned academicians. So first of all, I would like to welcome our guest Dr. Kakkar in EduSet lecture. Sir, over to you. What is simulation?
Yeah. Okay, welcome viewers. This is in continuation of my lectures on the subject operations research. In the last lecture we discussed game theory, and now today we'll devote some time to know about simulation. What does it mean and how to operate simulation to get a solution to our specific problems. First, we should understand the meaning of simulation. Simulation is making a model of our problem, then studying it thoroughly, then implementing its some solution to this problem on the model, get the results. If there is any change required, make a change, get yourself satisfied, and then use the solution for the real world problem. This is a basic meaning of simulation. And simulation people are using for the last so many years to find a proper and effective solution to their problems. How this particular tool is to be used to get proper and effective solution, today we are going to see the complete process of simulation. In this case, one has to understand why we are not implementing our solution on the real world problem itself. Why are we making its model? Means simulating the entire conditions what the problem has. The answer to this question is very simple. I have a solution to the real world problem. Again, I am not sure whether it will work or it will not work. So first I will try to find its impact, the impact of the solution on a part of the problem, and then see its results. Sometimes implementing the complete solution on the complete problem, it becomes disastrous also. When it becomes disastrous, there is no way to come back. So that's why we implement the solution on the simulated model first and see its impact. The second benefit of simulation is we make a model of the real world problem, and this model has all the features of the real world problem. And then if we have miniature of the problem, we can see the problem thoroughly from all the angles. When everything about the problem is known to us, then the solution becomes easy. Then we find out the solution, and then solution is implemented on the simulated model and its impact is seen. If it is working, we will use this method on the real world problem. If it is not working, we will find some other solution. If it requires some changes, we'll bring about those changes in the solution which has been designed for the simulated model, and finally we'll implement the solution on the real world problem. This way we will be sure that our solution will work on the real world problem. I can explain this with one example. Suppose in a factory which is manufacturing certain product, it has departments like manufacturing, engineering, purchase, finance, marketing, and so on. The problem in this organization is that the employees come late, and if people are coming late, then all the operations get delayed and the quality has a bad effect, and the management wants to find a solution to this problem. And then they discussed in the meeting and found a solution. The people who will come late will not be allowed to enter the factory, and this was the solution. Next day morning, and this solution was implemented on the entire organization, and people found that more than 40% came late and they were detained at the gate, or they were not allowed to enter the factory. In such a condition, when more than 40% employees are late, the operations in the factory cannot run. The entire production in that factory came to standstill on that particular day, because we found a solution and we implemented a solution on the real problem where entire organization was involved and the production came to standstill. This is not a healthy situation. Now people have come up with some idea. They have given an idea that we should implement this solution on a part of the problem. Say different departments are there in the organization. Why not to implement this solution only in one of the areas and see the impact? If this solution is working, then this solution can be implemented on the entire organization. Otherwise, this solution will be discarded and some new solution will be found. At this time, with this new idea, they thought of implementing this solution in a part of the organization and in a part of the functional area. They decided to see the impact in the quality assurance department. And this quality assurance department was operating in two parts. And in one of the parts of the quality assurance department, they implemented the solution that latecomers will not be allowed to one part of the quality assurance department. As found in the entire organization, this time also, more than 40% employees came late and they could not run that part of the quality assurance department. And the lesson is obvious, as the result is also obvious. The lesson is that you cannot stop the workers who come late. Some other solution is to be found for the entire organization. So this gives us a hint that the solution which we have found is not effective, it should not be implemented, otherwise disaster will happen in the organization. So this is the meaning of simulation and this is the use of simulation. So have a model of the entire problem in front of you and then find a solution to this problem and implement the solution in this particular model and see the results, see its impact and finally implement the solution on the entire organization. Now we will see the entire process of simulation. What exactly is the meaning of simulation? What is it? It is a technique that involves setting of real situation and then performing experiments on the model. We have a model of the real world problem in front of us. Then whatever experiment we want, we can experiment it on this particular model and see the results. Look, this is a photograph. Horse simulator. A wooden horse is made as a simulator for the real horse. And the army people are trained how to sit on this particular horseback and look at the photograph. People are training, people are learning. So this is a simulator for the real horse. Simulation is the imitation. Imitation means copy of the operation of a real world process or system over time. The act of simulating something first requires that a model be developed, and this model represents the key characteristics or behaviors or functions of the selected physical or abstract system or process. One has to understand simulated model should represent the entire characteristics of the real process. There should not be anything which is missed out. Now, let's assume X simulates Y, where Y is 2 and the real entity. X and Y are formal systems. One has to understand each statement thoroughly. Y is taken to be the real system. I'll repeat, X is simulated model where Y is the real system. X is taken to be approximation to the real system. So X is approximation of real system Y. And the rules of validity are, what are the rules? Non-error free. Otherwise, X will become the real system. What does this statement state? X is a model of the real process Y. X cannot be exactly similar to Y, X cannot be congruent to Y. If it is so, then X is nothing but the real system. So, one is to understand that X cannot be just equal to Y. X is a simulated model. There will be a difference between X and Y. Y is the real system, X is the simulated model. Then objectives of simulation. What are the objectives? Evaluating design alternatives for some new operating system. We have existing operating system. We want to make a change in that operating system. We have to evaluate all those possible alternatives. those cannot be tried on the real system, we will have a simulated model of that real system and apply all those modifications what we want to see. Then examining the effects on an existing system of changes in that system's environment. We have listed many alternatives to make changes in the operating system. One by one we will implement those changes in the simulated model and see the differences it make to the environment. Because we are doing the changes only the simulated model, not on the real world. Or exploring alternative modifications to existing system. We have to explore also. If we don't have the list of alternatives, we can explore the different alternatives for making modifications in the real system. These are the objectives of simulation process in management field. Now we'll discuss using simulation, observation of a physical system. Physical system is to be seen thoroughly to know all its characteristics, all its features. Then formulation of a hypothesis or a mathematical model out of all these features. When we make mathematical model, it can be subjected to the changes what we want. It can be subjected to modification what we want. And then when modifications are introduced, we can see their impact also. Usage of mathematical or logical deduction for predicting the behavior of the system. We have a mathematical model, simulated model of the real world problem. And this is logical, and we can have logical deductions from the changes made in this particular model. What are the advantages of using simulation? What are the benefits? Simulation enables experimentation with complex system in an inexpensive way. Very simple. We have a model of the entire process in front of us. And that system, the real world system, is very complex. If we make a change in it, things can so happen that we are not able to control it. On the other hand, the same complex system is seen in a simulated model. If we make changes in that model, even if we are not able to control, it is not going to harm us. But it will give us a lesson that modification suggested will not be under control, something else is also to be introduced, or this modification, what we have thought of, should be abandoned. Third option is available. Modification, what we have thought of, must be changed and then implemented on the simulated model and see its impact. So this is advantage. Interacting system, variables can be studied and the effect of changes in these variables on system performance can be understood. What all variables are involved in the process, same variables will be seen in the simulated model and changes will be introduced in this simulated model, changes in the variables, changes in the features of the variable also will make those changes and then see the result. Simulation can be used as a pre-service. We are discussing the advantages of simulation. So simulation can be used as a pre-service test to try out the new policies and decision rules for operating a system before running the risk of experimentation in real system. It is being repeatedly emphasized that to avoid problem, to avoid disaster, we make a model of the real world problem and implement the solution what we have thought of to see its impact. Simulation can be used as a verification tool for analytic solutions of complex problems. Problems are very complex. Of course, the solutions will also not be so easy. Complex solutions implemented, we may have complex results. Maybe those results make the process out of control. Then try it first on the simulated model and then see the results. Some terms which are used in simulation we have to understand before we go to the exact process of simulation. First is random variables and numbers. Simulation models consist of what? Components, variables, parameters, and functional relationships. Four things we are going to discuss. Components, variables, parameters, and their functional relationship. And components, these depend upon the system to be simulated. We know the system and then we know the components also. We are talking about components and the components of the system which is under study, and even variables also of the system which is under study. Variables in a model relate one component to another. How the variables are related, and that functional relationship will give us. Parameters. What do I mean by parameter? Parameter define the probability function of input variables. There are input variables which can be changed, and then we have the result from the input variables. Then we have a process. Then we have the output. And what do I mean by functional relationship? Functional relationships describe the interaction of variables and components of model. There are 4 or 5 variables. If I make a change in one variable, the result could be there is no change in other variables, but it can so happen that one of the other variables also change. Then we say that there is an interaction between these two variables. This is the meaning of interaction of variables. Simulation models. There can be 4 different types of simulation models. The first one is deterministic. In these models, input and output variables are not permitted to be random variables, and models are described by exact functional relationships. The meaning is that input variables are same all the times. Their amount is same, their specifications are same all the times, as they are deterministic. Deterministic, they have finite value. For example, if a chemical is being used, its concentration is fixed, its temperature is fixed. If a gas is being used, its pressure is also fixed. there cannot be any change in these values. If we are fixing all the specifications and the variables which are input to the process, then definitely the output will also be fixed, and this is called deterministic model. Now we have another model which is called stochastic. Stochastic, the meaning of stochastic is, it is a probabilistic model. Some probability is attached to the different variables. In these models, at least one of the variables or functional relationship is given by the probability function. So, in contrast to deterministic, we have probabilistic model which is known as stochastic. There are a number of variables. Even if one variable is not deterministic but it is probabilistic, we will call the model as stochastic. Third model is static. These models do not take variable time into account. So these are independent of time. If something is independent of time, then it is static. If it depends upon the time, then it is dynamic in nature. But our model is static, so it is independent of time. There is no impact on the results or on the use of variables as far as time is concerned. Dynamic, these models deal with time varying interaction. What is the impact of time on the variables, whether these are input variables or output variables? We take into account the time portion also into our study. Now there is a Monte Carlo method of carrying out simulation process. What is it? We are going to discuss now. Monte Carlo method of simulation. Monte Carlo method or Monte Carlo experiments, one and the same thing, are a broad class of computational algorithms that rely on repeated random sampling to obtain numerical results. Typically, one runs simulations many times over in order to obtain the distribution of an unknown probabilistic entity. There are 2-3 things we have seen here in Monte Carlo method or Monte Carlo experiments. One is randomness and then the probability. In the subsequent slides, we will try to learn the meaning of random and meaning of probability attached to it. The name Monte Carlo comes from the resemblance of the technique to the act of playing and recording results in a real gambling casino. Monte Carlo is the name of the place where gambling and betting games are played, and this has been taken from that Monte Carlo method of simulation. They are often used in physical and mathematical problems and are most useful when it is difficult or impossible to obtain a closed form expression or infeasible to apply a deterministic algorithm. Very clear. This method is used where deterministic results are not expected, where the outcome is probabilistic. Only in those situations we use this Monte Carlo method, which of course depends upon random numbers. We'll know the meaning of random numbers and then the probability. Monte Carlo methods are mainly used in 3 distinct problem classes. What are those 3 distinct classes? One is optimization. Second is numerical integration and generation of draws from a probability distribution. Again, he is talking about probability distribution, probability function distribution. We'll discuss what is meant by probability function and what is meant by random numbers. Before the Monte Carlo method was developed, simulations tested a previously understood deterministic problem, and statistical sampling was used to estimate uncertainties in the simulations. Monte Carlo simulations invert this approach, solving deterministic problems using a probabilistic analog. Here one has to understand how this Monte Carlo process works. First, the results of the analog system, deterministic in nature, are observed thoroughly. And then Monte Carlo simulation technique is used, which is probabilistic in nature, and this will solve our deterministic problems. How the process is used, we are going to discuss in further slides. Monte Carlo simulation is normally understood as a communication process involving random numbers. What are these numbers? How these are obtained? We'll see it right now. Random number. Random number is a number chosen as if by chance from some specified distribution, such that selection of a large set of these numbers reproduce the underlying distribution. Almost always, such numbers are also required to be independent, so that there are no correlations between successive numbers. This definition of random number is to be understood properly. There is a randomness in the selection of numbers. If one number is selected now, second number selected, there should not be any relation between these two numbers or the numbers which are selected subsequently. They should not follow any relation. And then each number has a same probability in getting selected. If such is the case, we'll call these numbers and their selection random. Numbers are called random numbers. The selection process is random in nature. So there is no direct relation, or even there is not at all relation between selection of numbers, and these numbers are then called random numbers. How to get these random numbers? So when we are to use the random numbers, we must have something who will give us the random numbers. A simple process is use a generator. This generator will give you random numbers, and this is also called RNG, random number generator, and it is a computational or physical device designed to generate a sequence of numbers or symbols that lack any pattern or any relation. There is no pattern, there is no relation between the numbers, but these are random in nature. A generator will give you series of random numbers. These can be 1 digit, 2 digit, and 3-digit and multi-digit numbers. We'll have to define how many digits in the random numbers we want. Then this particular generator will keep on giving you random numbers. And we'll have to use these random numbers in getting a solution to the real world problem, making a simulated model of that particular real world problem. So random numbers, random in nature, no relation between subsequent numbers. There is no pattern also in the selection of numbers, and these are called random numbers. Let's see one example, and that will show us the process of Monte Carlo method in simulation. An ice cream parlor's record of previous month's sale of a particular variety of ice cream is as given in the table. We are studying the sale of ice cream bricks in a particular parlor, and we have a past month's data with us, and this table is giving us the past months, the previous month's sale of ice cream bricks data. It has two columns. The first column tells us number of bricks of a particular variant of ice cream brick, and the second column gives us number of days. So one has to understand this table. 4 bricks were sold on 5 days, and 5 bricks were sold on 10 days, and 6 bricks were sold on 6 days, and 7 bricks were sold on 8 days, and 8 bricks only once, means 1 day. If we total the number of days, these are 30 days in a month. So 1 month's data noted. Again, now the problem with us is we want to simulate the demand for first 10 days of next month. Based on the data available, we have to see how many bricks will be sold on first day, how many bricks will be sold on the second day, and similarly how many will be sold on third, fourth, fifth, like this, and for the 10 days of the next month. So this is a problem. I will now demonstrate how we are going to simulate this demand. Past data is available, and we are going to use Monte Carlo method of simulation, which uses random numbers and the probability. Solution starts with finding the cumulative probability and assign a set of random number intervals to various demand levels. This states that we have to find out the cumulative probability, and with this cumulative probability we will write the random number interval. How? We will see in the next slide. The table gave us the demand and the number of days, and from the previous table we will calculate the probability. Let's go back to the previous table. 4 has a probability in the sense that number of days means 5 days, 4 bricks will be sold. Total days are 30. 5 by 30, we have to see 5 by 30, and we will write the probability. 0.17. Similarly for 5, it is 0.33. 6 it is 0.2, 7 it is 0.27, 8 is 0.03. Clearly understood? Let's go back again so that there should not be any doubt in our mind before we proceed further. How this 0.17 has been calculated, 0.33 has been calculated. Okay, 5 by 30, 10 by 30, 6 by 30, 8 by 30 and 1 by 30 is the probability. When this probability, individual probability has been taken into account, mind it, the total of these probabilities will be nothing but 1. One can add and find out oneself that the total is 1. Now we have to see the cumulative probability. 0.17 will be written as 0.17 as such, but against 5 we'll write 0.5, and this 0.5 has come from 0.17 plus 0.33. Similarly, 0.7 has come 0.5 plus 0.2. 0.97 has come 0.70 plus 0.27. And finally, 1 has come 0.97 and then add 0.03. This is cumulative probability. And we have to attach random numbers. As the cumulative probability and the probability are calculated to the accuracy of 2 digits, then we'll use 2-digit random numbers. The first one will have interval of 0 to 16. Why 16? 1 less than the cumulative probability. Cumulative probability is 17 and 1 less is 16. So 0 to 16 is the first interval. Second, we'll start from 17, the next number, and we'll go 1 below the cumulative probability. 1 less than the cumulative probability is 49. So we'll write the next random number interval as 17 to 49, similarly 50 to 69, and then 70 to 96, and the last 97 to 99. So the second step is also now over. First was probability in the given data. Now cumulative probability and the random number interval are calculated and written in the columns. The next step, 10 random numbers selected are, we have to pick 10 random numbers. Why 10? Because we want to forecast the demand for next 10 days. So we'll have the random numbers 10. And let's see, these are the random numbers. Where from these numbers have been selected? Already I have explained, one can use RNG, random number generator, or these numbers are available in the books. At the end, these tables are given in almost all the books which cover simulation. If you use Excel, you have the random number generator in that, and from the Excel software you can get these numbers. So let these numbers are taken from any source. The numbers are 17, 46, 85, 9, 50, 58, 4, 77, 69 and 74. Now we have to see these random numbers are there and how to pick the demand. For this we will have to go to the previous table. The first number is 17. Go to the previous table. Random number interval 17 is in the second row, and this is in the interval 17 to 49. So we'll pick the demand from this row. Against this row, there is 5. Demand is 5. So we'll write first day's demand as 5 number of bricks. Next is 46. Next random number is 46. How to note down its demand? Just now we saw the interval is 17 to 49. So 46 number lies in this particular interval, and this interval has a demand of 5 bricks. So we'll write 5. So this is what is written also. The second day the demand of number of bricks of ice cream will be 5. Okay, now we'll see what is the situation on the third day. Third random number is 85. We'll see against 85 what is the demand. We'll go to the previous table. 85, rather 58. Against 58, 58 lies in the interval 50 to 69. So we'll write the demand taken from this particular column. Similarly, other random numbers and their demands are noted from this table. Random number interval where it lies against this particular interval, will note down the demand. Okay. So it lies in 85 lies in 70 to 96. So against this 70 to 96, the demand is 7 bricks. We'll see whether we have written 7 or something else. So 85 we have written 7. Now we'll go back again. Next random number is 9. So against 9, what should be the demand? We'll go to the previous table. 9. Look at this table and see that 9 random number lies in which interval? And this is the first interval, 0, 0 to 16. 9 is part of this interval, and against this the demand is only 4. So we'll have 4 bricks, and we'll write it in the 4th day. 4th day the number of bricks sold will be 4. And similarly for all other days, we'll note down the demand of bricks. And this is a very simple method using Monte Carlo technique, using random numbers, and then finally predicting the demand for the future. We'll see one more example. Again, I have put a question. Why 10? Clearly, I have already explained. 10 random numbers are taken because we are to generate demand for next 10 days only. Because we want to simulate demand for first 10 days of the next month. We'll see one more example. Before that, we'll see the advantages and disadvantages of simulation. I have demonstrated the Monte Carlo method using one practical example. It is relatively straightforward. There is no complexity. There is no problem in understanding and implementing simulation. Recent advances in software make some simulation models very easy to develop. We have software, a number of software available which have made this process more simpler. It can be used to analyze large and complex real world situations that cannot be solved by conventional quantitative analysis models or manually. Simulation allows what if. A answer to this question, what if this happens, what if that happens. So simple answers are given by this simulation technique. types of questions. Managers like to know in advance what options are attractive. With a computer, a manager can try out several policy decisions with a matter of minutes and seconds. And without implementing the solution, you will find out the results of that solution in advance. If you like the solution, if you like the results, you can implement that or otherwise change the solution or make some modification on the solution. Simulation do not interfere with real world system. Why it doesn't interfere? Because our solution and our model is independent of the real world problem. We have made a model of the real world problem and implementing the solutions through the model only. It may be too disruptive. For example, to experiment with the new policies or ideas in a hospital, school, or a manufacturing plant. When these complex solutions are there, they may lead to complex results and complex problems if implemented in the real world. So we implement them on the simulated model. With simulation, experiments are done with model, not on the system itself. This is a major benefit of simulation. Simulation allows us to study the interactive effect of individual components or variables to determine which ones are important. Now we are implementing the solution on the model and we can see the variation in results, changing variables one by one and see the impact. Then we can see the quantifiable results also. The one which is the most useful, that particular solution will be implemented. Time compression is possible with simulation. The effect of ordering, advertising, or other policies over many months or years can be obtained by computer simulation in a short time. Things which will happen in months, years are now possible through simulation, through use of software and computers. Simulation allows for the inclusion of real-world complications, all the characteristics of the real-world problem in the simulated model. In the simulation models, any distribution can be used because it is simulated. We can simulate any distribution we want. There are disadvantages also attached with the simulation technique. Good simulation models for complex situations can be very expensive. Simulation does not generate optimal solutions, as do other quantitative analysis techniques such as EOQ, means economic order quantity, LP linear programming, or PERT, program evaluation and review technique. It is trial and error approach that can produce different solutions in repeated runs of the problem. Managers must generate all of the conditions and constraints for solutions that they want to examine. The simulation model does not produce answers by itself. One has to make the relevant changes and see the results and the impact of solutions. Each simulation model is unique. Why unique? Because it has unique changes involved in it. Its solutions and inferences are not usually transferable to other problems. One problem, one unique problem, and then one unique answer. As I discussed, we'll have a second example. So now we are discussing the second example. A dealer sells a particular model of the washing machine for which the probability distribution of daily demand is as given in the following table. Here in this table, direct probability is calculated. In the problem of ice cream bricks, we were given the number of bricks sold in 1 month. But in this particular example, the direct probability is given. The next step is, we want to know what exactly is to be answered. This is the question. Find the average demand of washing machines per day. Demand, zero demand has a probability of just 5%. One washing machine has a probability of 25% and so on. But how to go about it? We have to calculate the cumulative probability. In this table, we have cumulative probability calculated. We have noted down the random numbers and we'll proceed with our result. First, we have to complete the cumulative probability column, which is as 0.05, 0.3, 0.5, 0.75, 0.85 and finally 1. Very simple to make cumulative probability column. Then random number interval. Very simple. 1 less than the cumulative probability and starting with 0 to 4 is the first random interval. Next is 5 to 29. Next one is 30 to 49. Next is 50 to 74, 75 to 84 and finally 85 to 99. Now we'll see the random numbers. The first random number is 60. Where does it fall? It falls in the interval 50 to 74 where the demand is 3, we'll write 3. Okay, again 68 it is 3. 47 lies in the interval 30 to 49 where the demand is 2, 2 has been written, and similarly for other random number. For 92 it is 5, 76 it is 4 and so on. And the total is 28 and this is for 10 days. Average demand is 28 divided by 10. And in the normal method on the left hand side, how this is calculated. Okay, and normal method the demand is 2.55, but using simulation technique, Monte Carlo method, we are getting the average demand of 2.8. So this is the way to use Monte Carlo method, simulation technique to forecast certain things using random numbers. I have tried my best to explain the method of simulation. If the viewers are able to understand it, my efforts are amply rewarded and awarded. Thank you so much.
Thank you, sir. Thank you so very much. Of course, your efforts are rewarded because you have put so much of effort into preparing these slides as well as delivering such a productive lecture. Thank you, sir. Thank you so very much.
Thank you.